Hello, welcome back to Every Problem. This is Stewart, Calculus 8th edition, section 1.4, problem number 14. This is going to be a pretty quick one because the transformation is a simple one. So we have y equals e to the absolute value x. So what that means is every single input for x will in turn become a positive x. So if we plug in any number that's positive, it's positive. Any negative number, the x value will then be transformed to a positive number with the absolute value signs. Let me just draw that absolute value sign a little bit more clearly. I know it's fuzzy, so it's e to the absolute value x. Naturally, if we have some function, y equals b to the x, it's going to have an asymptote at y equals 0. Then it's going to have an intercept at the point 0, 1. And the graph is going to have this general shape. So if we have e to the x, the same apply, if we have e to the x, the same does apply. We have this asymptote here at y equals 0. We'll have a point of intersection at 0, 1. And if we started at 0, the graph would go up very quickly like this. Now, if we went in the negative direction, normally the graph would continue on, right? But because we have absolute value x, we're essentially going to mirror this right side of the graph to the left side of the graph. It's just going to look like this. It's a similar shape, similar to y equals x squared, you'll notice. However, because it's e to the x, right, the x is the exponent, not the base. Because it's e to the x, it's going to grow much faster. So if you ever wanted, you could use Desmos and graph the two. This doesn't have anything to do with the problem, really. I just am curious. If we have y equals x, let's see. I don't have my keyboard out, so I've never typed this out, but I guess just for fun, if you're interested, you can keep watching. Sorry for some of the noise. I'm just going to set up the keyboard really quick. We'll see what these look like. Here. Y equals x squared, and y equals e to the x. Oh, e to the absolute value x. There we go. So yeah, you can see it has a similar shape, but when we shrink the y-axis like this, you can see it grows much, much, much faster than x squared. So anyways, thanks for sticking with the rest of the problem. I just thought it was interesting.